So today we're going to look at 6-5, and we're going to add and subtract fractions. So we're going to look at, towards the end, and well, probably towards the middle too, some complex fractions, and that just means you have a fraction inside of a fraction. So some examples of some complex fractions might look like, it's so humid today with the rain, whoops, that my pointer, my stylus is sticking to my iPad. So 3/2 divided by 5. Or you could have x minus 4 divided by, actually I don't want that color on there. Let's look at x minus 4, try that again. So you'd have the fraction x minus 4 over x, and then all of that divided by 5x. Or x squared, that's a 2, plus 3x plus 2, all of that divided by x plus 3, and then that divided by x plus 2 over x squared minus 9. So all of these are considered complex fractions, a fraction inside a fraction. And then least common multiple. So we're going to look at least common multiple here and find out what, if these were both denominators in a fraction, what would you make them both into? So if you're looking at monomials, it's going to be far easier when we do polynomials. But if you look at monomials, we're going to prime factor the 12, prime factor the 15, stretch them out. So I'm going to start with the 12. I'm going to start way over here. So the 12, that's 2xy squared. So the 12 factors as a 2 and a 2 and then a 3, and then it's got 1x and then it's got 2y's. And I'm stretching these out for a reason. You'll see why in a minute. And then for my 15, I'm going to have 15x cubed y. So the 15 factors as 3 times 5, and I'm going to line up any like factors that it has with 12. So 3 lines up with the 3, and then the 5 gets its own column right here. It doesn't line up underneath anything, just like the 2's don't have anything beneath them. Then the 15 has 1x, so I'm going to line up 1x underneath the x from the 12, and it's got 2 more x's that will get their own column. And then the 15 has 1y, so it's going to line up with one of the y's. And then, to get your least common multiple, you're just going to bring down one number from each column. So you're only going to bring down 1, 3, not 2. 1, 5, 1, 2, 1, 2, 1, 3, 1, 5, 1x, another x, 1y, and another y. So let's find our least common multiple. So your LCM is going to equal 2 times 2, just one of the 3's, times 5, one of the x's, and then the 2 more that don't line up, one of the y's, and the 1y that doesn't line up. So then if you multiply 2 times 2, you get 4. 3 times 5 is 15. 4 times 15 is 60. And then you have 3 x's and 2 y's. So basically, you have to have, the 12 has 2's and 3's as its factors, and then some x's and y's. So you have to have at least 2 2's and a 3 in your LCM. Then the 15 has a 3 and a 5, so you have to have at least 1 3 and 1 5 in your LCM. and then it has 3 x's. So you have to have at least 3 x's because you have to have whichever one has the most items. You ought to be able to see all of these factors inside of here. And you ought to be able to see all of these factors inside of here. So even though it's the least common multiple, it's whichever of these two has the most of any one item. So 12 has the most 2's, so notice that you have 2 2's in the LCM. They both have the same amount of 3's and they each only have 1, so you only have 1 3 in the LCM. This has the most 5's and it only has 1, so there's only 1 in the LCM. This one, the 15, has the most x's and there are 3 x's, so notice that you have 3 x's in the LCM. The 12 has the most y's and there are 2, so notice that you have 2 y's in the LCM. So you always represent all factors between your two numbers here, but you always have the one that occurs the most often in the LCM. And we'll talk more about that as we do polynomials. All right. So then adding and subtracting, there are only 2 ways that you can add and subtract fractions. Same denominators versus different denominators. So if you have the same denominators, it might look like some fraction a over c, then you can have a plus or a minus, and then some fraction b over the same denominator of c. Since they have the same denominator, you can add their numerator or subtract their numerator, and you would put it over the same denominator. If they have different denominators, for instance, you have a over b plus or minus, and then c over d. You have to find the least common denominator between these two. So these are different factors, so you would just end up multiplying those together and you'd have bd. This one's missing the d from the least common denominator, so I'd have to multiply top and bottom by d. So this ends up getting a d multiplied to it, so you get ad plus or minus. This one's missing the b, and it needs the b to look like this, so you'd have to multiply c by b, so it becomes cb or bc. And then that's how it would look. Now a shortcut would be to do a times d, notice you get ad, b times c, you get cb, and then b times d, you get bd. So that's kind of a shortcut. Sometimes it doesn't always give you the least common multiple down here, but it will get you common denominators. All right, so let's look at some examples. So let's look at example 1a. So in example on 1a, you have 2 expressions, and you have to find the least common multiple between those 2 expressions. So the first thing that you need to do, and the directions are telling you to do this, is to factor each of your expressions. So the first expression, you can factor a 2, greatest common factor of 2, and you end up with 2 times x plus 2. Now my assumption here is that you do know how to factor. So if you have some questions about that, you can always text me. And then the second, the trinomial, factors as x minus 3 and x plus 2. So then you want to look at all the different factors. So in my LCM, I want to represent all the different factors that I see. So 2 is a factor, and x plus 2 is a factor. Factors are things that are being multiplied to each other. So these are 2 different factors. X minus 3 is different than these 2, but x plus 2 is the same as this one. So my only different ones are these 3 here. So I'm going to start off with putting all of my different factors, representing them here. Okay, then you want to look at each one of these factors and say which of these 2 numbers here has the most 2's. This is the only one with 2's and it has just 1 2, so only 1 2 is going to be in our LCM. Then which one has the most x plus 2's? Well, they each have an x plus 2 and they each only have 1. So only 1 x plus 2 goes in the LCM because that's the most times it ever occurs in any of these 2 situations. And then which one has the most x minus 3's? This one does, and then there is only 1. So that is our least common multiple, and I would highly suggest that you do not multiply it out. Just leave it factored. So then I want you to try B. If you're uncomfortable, you're still not sure, you can watch me walk through it. But if you feel comfortable, you want to try it, go ahead and factor each of the polynomials and then represent each of the different factors in all three of those polynomials and figure out which polynomial has the most of each of those factors, and that's your LCM. Okay, so this first polynomial, which it's a quadratic, factors as x minus 4, plus 4, x minus 1. This next one is x plus 4, x minus 2. And then this last one is x minus 2 squared, only because I recognize that it is a perfect square trinomial, and this is just factoring. Now, if you wanted to factor it, didn't realize it was a perfect square trinomial, the factors of 4 that add to give you 4 would be x minus 2, x minus 2. So you could write that out twice if you want to, that's fine. Then the LCM. So my different factors that I see, here's an x plus 4. Both of these have an x plus 4, so that's one of my different factors. And then x minus 1 is different than the x plus 4, and that's the only one that has an x minus 1. And then we already talked about this one, x minus 2, that's different, so I'm going to write that down. And then this is the same as this one. So then what you want to do is look at each of these three factors separately and figure out which of these three cases does it occur the most often. So with x plus 4, both this one and this one have an x plus 4, but the most times it occurs is once. So we're only going to have one x plus 4 in our LCM. The next one, x minus 1, only occurs in this first quadratic, and it only is to the first power, so we're only going to have 1 in our LCM. But the x minus 2 occurs here and here, but in this one it occurs twice, and that's the most that it occurs in any one situation. So we're going to put 2 in our LCM, and then this becomes our least common multiple. For example 2, we're going to actually perform our addition and subtraction. So not only are we going to have to find our least common denominator, which is least common multiple, but we're also going to have to make equivalent fractions using that same denominator. So for example 2, part A, you want to make sure that all of your denominators are fully factored. So this one is fully factored. So I'm going to put parentheses around the x minus 1. But this one we can factor an x out, so we end up with x times x minus 1. And so this gets rewritten as x times x minus 1. Then I want to find my least common denominator. So the different factors that I see are x minus 1 and an x. So x times x minus 1. The most times that the x occurs is here, and it's once, so only 1 goes in our LCD. Both of them have an x minus 1, and the most that it occurs any one time is just once. Once here, so only 1 goes in our LCD. So this actually has our LCD, so I don't have to do anything to change it. There is something on my screen that's driving me nuts. Sorry, it's gone. Okay, so then I want this denominator to look identical to this. It's got the x minus 1, but it's missing the x. So I have to multiply, get a good color. I have to multiply the bottom by an x, so it looks like the LCD, and the top by an x. So I'm going to go ahead and distribute this x into parentheses. So I get x times x is x squared. X times 1 is x, and then I am over x times x minus 1 plus, then I'm not changing the second fraction. So now I have the same denominator. That means I can combine the numerator into one fraction. So if I combine like terms, there are none, and I'm going to write the numerator in descending order. I get this. Again, you see me not multiplying out the denominator. then we want to factor this if possible. Are there any factors of 2 that add to give us 1? No. So this becomes our almost final answer. But we also need to state restrictions on the variables. So you always go back to your LCD when we're adding and subtracting, and you want to set each of these factors equal to 0. So x cannot equal 0, and x cannot equal 1. So those are our restrictions. All right, before you try B on your own, let's talk about one thing first. Notice that this denominator is y squared minus 16, and this denominator is close, but it's 16 minus y squared. So if you recall that there's a little trick that we can use, that we can factor a negative out from each of these. So if I divide this by a negative, I get negative 16. And if I divide this by a negative, I get positive y squared. Squeeze that in there. So now my negative 16 is the same as this negative 16, and my y squared is the same as this y squared. So I can really write it as negative y squared minus 16. Then you're going to take this negative, so we're going to cancel that one out and cancel that one out. You're going to take this negative and I'm going to move it upstairs. Well, if you take a negative that's in the denominator and move it upstairs, because remember in a fraction your negative can either be in the numerator or the denominator or hanging out to the side. So we're going to move that negative up to the top because I always want my denominator to be positive, so I'm going to move this up here, but that means I have to multiply it to everything in the numerator. So now I have the same denominator as long as I move that negative upstairs. So I'm going to have a y minus 9 over y squared minus 16, and then plus, remember I'm going to take this negative and multiply it to the y, so that makes a negative y, and multiply it to the negative 7, making a positive 7. So I have a negative y and a positive 7 over y squared minus 16. So now that I have the same denominator, I can combine the numerator into one fraction. All right, so I have the y and the negative y are going to cancel each other out, so I'm going to cancel those out. And then a negative 9 and a positive 7 is going to give me a negative 2 all over y squared minus 16. Now usually I would tell you to factor this in case it can cancel with this, but I know that this is not going to factor into something that cancels with this. So your answer can be this or the factored form, negative 2 over y plus 4, y minus 4. So this one actually didn't necessitate us to factor and find an LCM because once you move the negative, they were both the same denominator. Now we do still have to find restrictions, and so y cannot equal, if I look at the factored form, y cannot equal negative 4 or positive 4. So positive or negative 4. All right, so let's look at example 3. Now example 3 deals with subtraction. So the only thing that's different from what we were just doing is kind of what I was just talking about in example 2 part B. This negative has to be distributed to everything in this numerator. So we basically are going to create a, we'll end up creating an addition statement and then just doing what we did before. So I'm going to start off by factoring. So this is not factorable, but the trinomial can be factored into x minus 1, x minus 2. And so that goes away. And so in my LCM, my different factors would be x minus 1 and x minus 2. So those, out of these three factors, these are the only different two. So which one has the most x minus 1s? This is the only one, and it only has 1, so only 1 goes in my LCD. Which one has the most x minus 2s? They both have an x minus 2, and the most that they both have is 1, so only 1 goes in my LCM. So this fraction actually has the LCM, whereas this one doesn't. This one is missing in x minus 1. So x minus 1, x minus 1, and use parentheses. So I am going to distribute the x and the negative 1 and collect like terms all at the same time. So for the first fraction in the numerator, I get x squared. A 3x and a negative 1x makes a positive 2x, and then a minus 3. And then I am going to distribute this negative all the way through. So this gets distributed here and here. And so I have a minus 6x, but a positive 7. And all of that is over my LCD of x minus 1, x minus 2. Then you need to collect like terms here, so that's what we're going to do. The x squared has no like terms, but a 2x and a negative 6x gives you negative 4x, and then negative 3 and positive 7 gives you a positive 4, all divided by x minus 1, x minus 2. Then you need to actually refactor this trinomial to see if any of the factors here could cancel with the factors here. And it looks like it can, because x squared minus 4x plus 4 is a perfect square trinomial, or the factors of 4 that add to give you negative 4 would be x minus 2, x minus 2, or you can write it x minus 2 squared. So then I can cancel an x minus 2 with an x minus 2, and our final answer is x minus 2 over x minus 1. However, we do have restrictions. Now your restrictions need to be in your fully factored original denominator, or just look at your LCM. So even though we cancel this out, this still causes a discontinuity. So if you look at your LCM, x cannot equal 1 or 2. And there's your answer. So you go ahead and pause the video for sure this time and complete B on your own. Don't forget that you need to distribute this negative all the way through. All right, good luck. All right, so let's see how you did. This is not factorable, but the trinomial factors into x plus 5 and x plus 1. And so that one goes away. My LCM is equal to x plus 5, x plus 1. So this one has the LCM, so all I have to do is distribute this negative. This one is missing the x plus 1. All right, so if I multiply this through and collect like terms, I end up with x squared minus 1. And then I am going to distribute this negative all the way through. And I end up with a minus x and a minus 3, all over the LCM of x plus 5, x plus 1. Combine your like terms in the numerator, so x squared, and putting it in descending order, minus x minus 4, all divided by x plus 5, x plus 1. Then you want to see, can you factor this numerator? Are there factors of 4 that subtract to give you 1? No, there are not, but there are restrictions. So look at your LCM. X cannot equal negative 5 or negative 1. And so there is your fully reduced answer. All right, so we are going to simplify complex fractions, and there are two methods. Method 1 is typically the one I'll use. It just depends. But basically for method 1, you're going to look at the fraction within the fraction. You'll treat the numerator as a separate problem and the denominator as a separate problem. In other words, you're going to find a different LCM here than you would here. Whereas in method 2, you might end up making all 4 fractions have the same LCM, or the top having the same LCM as the bottom. Sometimes that's what you do, sometimes that's what you don't do. It just depends. I typically will follow method 1, and it just so happens that I end up with the same LCM in both places. So let's look at the 2 problems. So for A, I have one that's a fraction and one that's not. So if you have one that's not a fraction, you're going to make all of them a fraction. So if you look at your LCM for the numerator, you have a 1 and a 2, so your LCM is going to have to be a 2. Your LCM for the denominator would have to be a 7. So a shortcut to actually changing them both into the same LCM, so if these are both 2, this one has the LCM, this one's missing it. So I have to multiply top and bottom by 2. So I get 2 times x plus 1, and then they'll both be over 2. Well, the shortcut to that is just take x and multiply it by 2. You get 2x. And then take the 1 and multiply it to the 1, and you get a positive 1, all divided by, and then multiply these 2 together. 1 times 2 is 2. And then they're all divided by, and do the same thing for the denominator. X times 7 is 7x. And then this negative belongs to this fraction, so we always will push it up in the numerator. We always like our denominators positive. So consider this negative belonging to the 1. So I already did 7 times x was 7x, so 1 times negative 1 is a negative 1 over, and then 1 times 7 is 7. So then from here we're going to treat this as a normal division problem. So we're going to do keep, change, flip. All right, so I'm going to keep the first fraction. We're going to change the division into multiplication, and then we're going to flip the second fraction, and I get 7 over 7x minus 1. So I just flipped it. Then you're going to factor this if you can. You can't. Factor this if you can, but you can't. And of course you can't factor those. So instead we're just going to multiply straight across. So I end up with 7 times 2x plus 1 over 2 times 7x minus 1. Now because nothing can cancel, I can't cancel these at all, or I can't reduce these, you can leave that as your answer, or you could actually multiply it through. So 7 times 2x would be 14x, and 7 times 1 is 7, divided by, and 2 times 7x is 14x, 2 times negative 1 is negative 2. Now because you have addition and subtraction signs outside of parentheses, you cannot cancel these 14x's. Then don't forget you have restrictions. So you want to look at your fully factored denominator in your multiplication statement. This does not have a variable associated with it, so there's no way that we can create a 0. However, this, if you set it equal to 0, you'd have to add 1 and divide by 7. So your restriction is x cannot equal positive 1/7. So you have this or this plus the restrictions. All right, so you try B on your own. Pause the video and check your work. So for B, you were going to notice that they both have an x and a y and an x and a y. So if you try to create one fraction up top and one on the bottom by using the method I just showed you, look what happens. So you get 3 times y is 3y. And then x times 4 is 4x, so positive 4x, divided by, and then x times y is xy. Then all of that is divided by This negative belongs to the 3, so y times 4 is 4y. X times negative 3 is negative 3x divided by x times y is xy. So then you're going to keep change flip, so I'm going to keep the first one, 3y plus 4x, all divided by xy. I'm going to change division to multiplication, and then I'm going to flip the second fraction. So the xy is going to go up top, and the 4y minus 3x is on the bottom. And then you're going to factor. Well, I can't factor this, and the monomials cannot be factored. So you can just start canceling. This x with this x, this y with this y, and that leaves you with 3y plus 4x all over 4y minus 3x. And of course you have some restrictions. So the restrictions on here are a little odd. So if you look at your multiplication form, you have a monomial here, so clearly x cannot equal 0 and y cannot equal 0. But then this one has two variables. So if I'm going to kind of do this off to the side, so if I took this denominator right here and set it not equal to 0, you're going to have to solve for either this term or this term, because this term is negative. You're going to push it over here. So you get 4y is equal to 3x. I'm happy with that as an answer, but some teachers might want you to solve for y. So you could divide this side by 4 and this by 4 and get 3x over 4, or solve for x and divide by 3. But I don't see a reason for that. So just so long as the product of 4y does not equal the product of 3x, you're good to go. So there's your restrictions and your simplified fraction. All right, so we are going to look at a little bit of a challenge, not too much of a challenge for y'all, but we've got complex fractions that are being added or subtracted within a fraction. So I'm going to find the least common denominator for this and for this separately. So the LCM for the numerator, if you look at your this is fully factored and this is fully factored. So each of these factors have to be in your LCM. So I've got x times x plus 1. And so this one is missing in x plus 1. And so this has to get multiplied by an x plus 1. And then the second fraction here is missing the x, so then the numerator has to get multiplied by the x. So I'm going to FOIL and collect like terms at the same time. So x times x is x squared. Then I get an x and a negative 2x, giving me a negative x. Negative 2 times 1 is negative 2. And then plus 2x, so plus 2x, all divided by the LCM of x times x plus 1. And then all of that is over. Then I'm going to find the LCM for this group. So the LCM for the second group, again, this is fully factored and this is fully factored. So each of those factors go in my LCM, and they each only occur once. So the first fraction is missing x plus 1. So I'm going to multiply that one by x plus 1, and the second one is missing x minus 1. But don't forget that we have this negative here. So this negative is going to be pushed to the numerator. So I'm going to plus a negative. So that's how I pushed it. I pushed it to the numerator. So that way I'm going to distribute a negative 1 into here. So I'm going to distribute a 3 into here. So I get 3x plus 3. Then distribute the negative 1 into here. So I get a negative x plus 1, all divided by my LCM of x plus 1, x minus 1. And so then I'm going to keep change flip, and I'm going to collect like terms while I'm doing it. So I'm collecting like terms here. I'm keeping this fraction. So I get x squared. Minus x and 2x gives me plus x, and then minus 2, all divided by x times x plus 1. And then instead of division, I'm going to multiply. And I'm going to flip this fraction and collect like terms at the same time. So my denominator, whoops, wrong color. My denominator is now my numerator, divided by, and then my old numerator is 3x minus x. So 3x minus x gives me a 2x, and then 3 and 1 gives me 4. So now I want to factor everything. So this can factor into x plus 2, x minus 1 over x times x plus 1 times x plus 1, x minus 1 over, and then this can factor into 2 times x plus 2. So now I can cross cancel, so I can cancel an x plus 2 with an x plus 2. I can cancel an x plus 1 with an x plus 1. I cannot cancel the x minus 1s because they're on the same level. So I have two x minus 1s, an x and a 2. So I have x minus 1 squared, or you can write it out twice, and then 2x. And then my restrictions, x cannot equal. So if you look at your fully factored multiplication, x cannot be 0, -1, this won't cause a 0, and -2. So 0, -1, and -2. Done. Now you pause the video and try B on your own. So B doesn't even require an LCM because it's one fraction over a fraction. So you just have to factor, 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 factor. So that's what I'm going to do. I'm going to start by factoring. So my numerator would be x minus 3, x plus 2, divided by my denominator, x minus 7, x plus 2. All of that divided by my numerator would be x plus 5, x plus 1, divided by x minus 7, x plus 1. So then I'm going to keep change flip. So if I keep, I've got x minus 3, x plus 2, divided by x minus 7, x plus 2, change, I'm going to change division to multiplication, and then I'm going to flip this fraction. So I've got x minus 7, x plus 1 up top, and x plus 5, x plus 1 on the bottom. The x plus 2's cancel, the x plus 1's cancel, and the x minus 7 cancels. So you're left with x minus 3 over x plus 5 with restrictions. So look here, x cannot equal 7, -2, -5, -1. So 7, -2, -5, and -1. And we are done. Good luck with your homework. Text me with any questions.